I'm Mike Romero. Pretty much already introduced me. One thing I really want to go over, guys, a lot of things I've been seeing out there. The quality of installs that are getting done, I think people are trying to bang them out. They're not routing the wires correctly, or they are, but we're having comebacks because, not because it came out of tune or because anything else as far as the tuning goes on. What's happening is the installs are getting done not correctly. So the wires, we've had cars, we had a bunch of cars yesterday. They're supposed to be here for tuning, and we've got wires that are improperly routed. So now you got cross shorts, you got wires melting, you got, you know, the thing first worked when it got installed the first time, and then the customer comes back and says, well, it's not working no more. Well, it's not the system, it's the installer, the longevity of it. I've had people bring me vehicles that are supposed to get tuned, and you know, we got 2x4s and plumbing tape holding the fuel cells on. You know, you got to compensate for road conditions. When I do mine, I use solder and heat shrink. I do not use any butt connectors whatsoever, period. Because you got to, we're dealing with oxygen sensors that are dealing with 0 to 1 volts. Any type of corrosion that gets in that circuit because of a butt connector or anything like that's going to add resistance to the circuit, thus messing with our signal. And then that's where those fuel mileage decreases are going away. So what I really want to stress a lot about is getting that quality of the install. I think that you guys need to make sure that you take pride in your work, route the wires properly, secure that fuel cell, you know, educate your customers on how it works, what to do, what not to do. The little sight glass on those fuel cells, every one I've done, I've never had a problem with caustic getting in the throttle bodies. I've seen a lot of them getting caustic in the throttle bodies, and part of it's because they're overfilling the fuel cell, so the water starts coming out, starts getting drawn into the system. So I don't know, the best way, what I've been doing is making a little mark on that hose, and you got to educate your customer. It's not one of those things that you just put on there, bang it out, let it go, and that's where these comebacks are coming from, and that's what we're trying to eliminate. These new ones have a nice bracket which should help on the mounting a little bit better, but the ones I do, you know, just get some strap steel, make you some angle brackets, tack weld them on. I'm also going to address a few problems that I've encountered that I came up with a quick fix. It's not a big deal. We're increasing the temperature of the engine, as you guys all well know that. So most vehicles have an idle air control valve or some kind of device that controls the idle on cold starts or, you know, on a hot engine. Well, because we're telling the ECM that the engine's hotter than what it normally is, that idle air control valve is going to plunge all the way forward. Thus, sometimes with a dirty throttle body, worn out throttle body, that's where those shaky idles come from. So I really strongly suggest that you guys clean the throttle bodies beforehand. Also check the voltage. If you have to adjust, give it a little more air to breathe. I call it a minimum airflow adjustment. You guys have probably heard of that before. These numbers are not etched in stone, but I'm going to just give an example. That's a minimum throttle position sensor at idle. That's what the call calls for. So if you have a car and the ECM, as long as it sees 0.58 to 0.85 at idle, you're not going to get a check engine light, right? Now we get a tech that goes in there because he's got a shaky idle and cranks up the idle screw. What's it going to do to that voltage? It's going to make it go higher. So I strongly suggest that we check that voltage. If you're going to crank up on that screw, if you're going to change the idle, and make sure we're not passing that threshold. If we are, there's two ways to address this. One, a lot of cars have an adjustable throttle position sensor. So let's say you crank it up and it goes to, when we first started out, we were at 0.75. Now after, when we got a smooth idle and we got it where we like it, now we go and check it and we're at 1.1 volts. A lot of TPSs are eccentric or they're adjustable. All you got to do is go back in there, loosen the 2 Phillips screws or Torx head, back off that TPS so you're back in that range. There's the check engine light problem solved. If you have a non-adjustable TPS, you have a throttle plate. We did a few yesterday here that had that problem. Here's your throttle plate, your butterfly. I don't know if anyone in here does performance stuff, but I've done a lot of throttle body replacements through BBK and other Holley throttle body upgrades. Aftermarket companies come with these, which we can also modify our stock one to do so. You get a small little drill bit and you're going to just drill a hole right there. That's going to give us that little bit of extra air because we're not getting it through around that throttle plate. If you have a non-adjustable TPS, we don't want to crank down on that screw because we're not able to back off that TPS. All we're trying to accomplish is to give that engine a little bit of air to idle because it's not getting it. So if you drill a little hole, put the air boot back on, see what it does. If it still got better, runs a little shaky, increase the size until you get it to where you get your idle drivability back. We've had to do that on quite a few, but most of them, the throttle bodies, when they come in there, are already all carboned up and coked up with grime. And they stick and all kinds of fun stuff. Before you guys install these kits, make sure the car's a good candidate. If the car's running on 3 cylinders, I mean, the drivability in the car isn't good to begin with, and now they want 100% increase on fuel mileage when, Make sure it doesn't have excessive blow-by. Make sure, it's a good candidate. Tune-up items are good. It runs good. Give it a good road test. Oxygen sensors are another thing you want to make sure that your O2s are switching good. We had an Oldsmobile yesterday. It was like a 1992 or 95. It was an Oldsmobile 98. That O2 would not switch at all. Typical oxygen sensor should be doing this. Sorry, this one's. Okay, this one we had yesterday was doing this. Okay, so 2 things could be the problem. 1, we got a bad O2, or 2, that engine's not getting any fuel. So what did we do? I enriched it with propane. I made it run rich. This thing should have gone like this if we had a good O2. That would tell me my oxygen sensor is good because I just added fuel and it skyrocketed up here. I added propane and it still stayed down here. You think that O2 is good? Propane. Just a propane, those ones they use for lanterns or anything. They sell them with a little valve that you can turn on, put a little vacuum hose, stick it in the air intake, flood it with propane. That O2 reading should go way up here. If we're getting an optimizer and we're using that input to change it, change the signal going into the ECM, how are we going to change something if we got an O2 that's flatlining? Do you get what I'm saying? You got to check these vehicles before you install these kits. I mean, most cars out there, that 95 Oldsmobile, it had, it was an older car already. Those O2s are probably worn out, You guys can make money there also. Tune-up items, plugs, wires, cap, rotor, fuel filter. A bad fuel filter, plugged fuel filter will cause that right there. You're going to get oxygen sensor lean codes. Does that mean the O2 is bad? No. The fuel filter is plugged solid and we're not getting any fuel. Anytime the ECM sees this right there, flat line, what it's going to do is it's going to, those long-term and short-term fuel trim numbers you guys see on your scanner, you're going to see them go positive because the ECM is going to say, I need to get this O2 to switch to up here. So it's going to start adding and adding and adding and adding fuel until it reaches its limit, and then you're going to get a check engine light and it's going to say oxygen sensor not switching. Okay. Sometimes I even use those to diagnose a fuel pump to throw me in that direction, or a plugged fuel filter, because if the O2 is not switching, you either got a bad O2 or you got a fuel problem. So there again, dump propane in it. If it comes up, then your O2 is good. You just got a type of fuel problem. You need to check fuel pressure and volume. O2 is a real important sensor because that's one of the ones that we're using to control fuel. Now, if the O2 is not working to begin with, well, we ain't going to be able to accomplish what we're trying to here. So I'm out in the field. I'm telling you guys what I'm seeing. You guys need to be aware of that. These numbers, these expectations of the HAFC cannot be met unless this criteria is met right here. You got to have something good to start off with. We've got a few cars out there that we have already screened and that are tunable. Yesterday we got cars that are supposed to be tunable, and we ended up ripping everything out and redoing everything because we've got installers that are installing improperly, or then the problems come back. We were just supposed to put them on the dyno and do tuning. So it's very important that you guys do these installs right. And if you have any questions, now's the time to do it, because you guys got some knowledgeable people here to help. Do you guys have any questions that I can answer? I don't really know what these guys have covered already. So
I've got one, and it's probably anybody probably can answer it but me, on this Ford pickup you just had in there.
Yes, sir.
Is there anything, whenever I go into the computer or with my scan tool, it always shows that drive cycle not complete.
Right.
Does that need to be some way completed to keep?
Do you have an emissions? Do they test emissions where you're from? Then no. OBD2 have drive cycles. Your monitors. You have to drive the vehicle in a certain manner for those monitors to work. You've got misfire detection, stuff like that. If the monitors are not on, then it's not going to be monitoring.
Do you have to go through the complete drive cycle for everything, or if like evac is trip the code on it, can you just do the part for that evac?
Yes, you could do that, but if you're in your Keep Alive memory and you got it on normal mode.
I'm not even hooked into the Keep Alive memory.
Okay. Well, it's going to adapt with time to that fuel cell, and then your savings are going to go away.
It will. Well, I see we're being taught two things here. Mike says, if I'm not wrong, that he'd rather stay away from that Keep Alive memory and retune if you have to a time or two or whatever. And Jim and now you are saying that we need to be in that Keep Alive and to interrupt it.
Every car's different. I keep it on normal mode if I can get away with it.
If you put it on normal mode, it won't
If you're from an emission state, then you're going to have to keep it in the IM mode.
When you go to inspection.
Right.
Yeah, but I'm not even hooked into it. I'm not even hooked into the Keep Alive memory. What?
Okay.
On that vehicle, if you
What
interrupt
that's doing by removing the Keep Alive is it eliminates the short term, which reverts back to the last previous long term. When you allow the short term to affect the long term by continuous drive cycles, eventually the long term will adapt to it. It'll try to revert back to what it knows. My recommendation was that if you leave the keep alive memory circuit portion of the optimizer out. You go back and you do a couple of tunings. As the long term adapts, you retune, then the adaptive memory will start working on your behalf instead of fighting you. The reason the adaptive memory keep alive circuit reset is in the optimizer so that you can be a business person, tune it in a timely manner, send it down the road, and it'll reset that short term every time you do another drive cycle.
That's okay, as long as if you don't have any
Okay,
problems.
but the vehicle.
Right, and if you do, like some vehicles,
It won't start.
when you disconnect that keep alive, the relearn process it's almost impossible. It's not drivable. When you flip that back to IM test, then there's no relearn process every time you restart, and the drivability is much, much better.
So it's going to be depending on the vehicle.
Yeah, it's going to be one vehicle to the next to the next.
Okay.
I've done all mine on the normal mode, but the only problem I've encountered is the idling problem, which I just told you guys how to address that. Every car's different. That's what's going to be, a little challenging because, the system does work, but that's why we got to make sure that you guys fully understand theory and operation and all these sensors that we're dealing with here. I've seen guys that tap into wires, they take it for granted because the wiring diagram says yellow with a green tracer or something like that. There's 5 yellow with the green tracers. You need to know that voltage. I always double check with a voltmeter my voltages, so I know I'm 110% sure when I'm tapping into that wire, I'm on the right wire. A lot of people are assuming, and that's where all these problems are coming from.
I got a question. On the air intake temperature and the coolant temperature sensor, are you finding on the ones that you've done, you've had to add resistance to them or no?
No.
The optimizer handles it pretty well by itself.
The intake air temp, most of them I end up clipping that little wire inside because it's showing too hot of an engine. That little,
the one wire.
that's inside, yeah. Sometimes it's the temperature's so high, if you clip the wire, it lowers the temperature.
What range are you finding is working good for you?
Every car's different,
Uh-huh.
but I increase the temperature by 15 degrees or so, and as long as I'm getting my timing where I want it, you got to look at that data before and after. I'm going to give an example of a couple cars I've done. Mike actually has that. He probably already showed you guys that map adjust. I did something not even close to as fancy as that, but we had a car yesterday, a van. Your map sensor is sensitive. The minute you turn the key on, it's going to look at the voltage, which is going to sense barometric pressure. Over here, we're close to sea level. I already know back home, almost every map sensor that I tie into reads 3.75 volts. That's how the computer knows the altitude difference. Okay? Now, if we're higher up in the mountains, do we have more or less air, guys? Less air. Do you think we need more or less fuel? Less fuel, right? Okay, we had a van yesterday here. It was reading 4.79 volts. Back home, I'm reading 3.75. Almost a whole volt difference. We ran this thing on the dyno under load, and our injector pulse width and we're monitoring our map voltage. Our pulse width at a cruise speed under load was approximately 9.5 to 10. It fluctuated a little bit. I set this thing as if it was in Las Vegas, New Mexico, where I'm from, and I didn't get a drivability problem because all we're trying to do is take away fuel. We're trying to lean it out. It went down to like 4.5 or 5 milliseconds. We shaved off almost half with no drivability problems, no lack of power, because we're getting our water gas in there. Is that not a guarantee? You just seen those numbers go down with your scan tool?
Use half the fuel, you double the mileage.
You're at a cruise speed with 9 to 10 milliseconds, and you just drop the voltage on the map. Computer thinks we're in Las Vegas, New Mexico. We're getting more air. We're getting water gas. And we're getting less fuel, and we're not getting no horsepower or power loss. Now, on the other hand, There was cars that we tuned yesterday also that we took away so much that the power started going away and you felt it, so we had to come back up. We passed that threshold. So it's just a lot of playing with them, and, you know, the more you do it, the better you guys will get. I do this for a living every single day, so my hands are always in it, whether I like it or not. So the guys that are just doing it, you guys need to just get in there and don't give up. Just play with it. That's what you got to do. Don't give up. Yes, sir.
Is there a way, if we don't have like your oscilloscope like you're using to see the pulse width there, can you
Well,
see?
a scan tool shows your injector pulse width on your data.
Good scan.
You're referring to the
I've got a relatively inexpensive scan tool. Can you just use fuel trim numbers to know whether you're getting a small enough pulse width? Or?
Really, there's some handheld scopes out there that ain't too expensive. Sometimes, let me tell you that my scanner, the way the PIDs are arranged, sometimes I can't look at both at the same time. So
That little orange one there, will that not give you what we need to?
I believe it will. That gives pulse width.
It does?
Yeah, that's $1.25. AutoZone.
Yeah, that should give you pulse width. But what I did on a couple vehicles, I actually, my map voltage, did just a regular voltmeter inside the vehicle, because I put my scanner so I could monitor my injector pulse width, and I had my voltmeter right next to it monitoring my map voltage. So at 60 miles an hour, I was at, let's say, 1.9 volts at a cruising speed, and my pulse width was 12. Okay. Well, when I dropped that map voltage down, I verified that I changed my voltage and my pulse width, and I'm monitoring those as I'm driving. I set everything up before I go do my road test. We have a dyno here. You guys will kind of see what we're doing. You showed them on the O2 already, pretty much, our in and out signal.
Yeah, that's part of the regular class.
Okay.
I did not recover very much of what's part of the regular class.
You guys all understand that I just gave an example earlier. When you got a O2 that's flatlining, it is running lean, but it is a rich command. That's telling the computer, give me more fuel. Okay? I think a lot of people are getting confused because they see it like that and they're saying, nice, we're making it run lean. No, it's a rich command. If you go look at your injectors or your trim, your short-term, long-term trim numbers, it's actually going positive. It's trying to give it more and more and more and more and more fuel. So it's actually opposite. If you see lean, it's going to give it more fuel. If you see rich, it's going to take away fuel. That's why when we're doing our tuning, the signal out of the optimizer, you know, it does step up, but we want to keep it longer, even if it's like that. You see this time down here that it stayed? It still switched. All the ECM cares is that it switched from lean to rich. That's all it wants to see. But if you were to measure this time here versus this time, how much longer did it stay up here? 3 or 4 times longer? It still switched? Okay. So for this 3 or 4 times longer that it stayed up here, did it not tell the ECM to take away fuel? Okay, and right here it said, give me fuel. Take away fuel. You see, that's what we're trying to do. You'll see there on the dyno, I can make it go exactly even versus that, just by turning that pot that these guys have incorporated in the optimizer. Do you guys, sorry. Is there any other questions? Does that make a lot of sense to somebody? Did that just help you guys out right there?
Yeah, that's good. But since we're talking about O2 sensors, I brought up to Mike a scenario I ran into with a GM product, I think it was a 99 Sierra pickup, I forget what engine. The 3X only switches down to 310 or 15, what is it? Millivolts?
0.36. Yeah, the 4X
Yeah.
is switched down to
Okay.
0.2 volts.
Yeah, so the ECU was looking at how many times it counted that it met the bottom end, but didn't meet the 300 what the ECM was looking for. So how do we overcome that now until the 4X is out?
Okay, the criteria on that,
Because it'll set codes.
well, I don't think so, because as long as it switches below 500 millivolts.
No, it's 300 the ECU is looking for, I read up on it. They're looking for it needs to go below 300 millivolts, and I think it was 600 and something or 800, I forget.
You read the
it.
criteria on the code?
I read
and
that
that's what it said?
in shop key, it's all lined out when you
Okay.
get this code, and the codes came on every time. But if
Okay.
you drive it long enough and the time expires where it counts, and it didn't get those counts, codes are set.
Well, you can play with the settings on it. You're not going to be able to max out like this then on that particular one, but you can still control to a certain point. You're just not going to be able to get as much out of it. And this is on what kind of
We're
vehicle?
not meeting, I think it was a 99 Sierra GMC, is that a GMC? I don't know what it is.
Yeah.
So, but the problem is we're not meeting with the 3X in place, we're not meeting the 300 millivolts the main ECU is looking for
Okay,
ever.
I would be curious to see, this is what that's why I told you you need to monitor the actual O2 before it goes into the optimizer. I'm going to give you an example. The optimizer reflects, or a mirror image almost changes depending on what it goes into it. So if you have an oxygen sensor, I'm going to just say you got a vehicle that, it's switching and it's going below normally, but let's say it's running a little fat or rich. You cannot manipulate this if this one's not switching correctly. So I would be looking at this O2 before it goes into the optimizer. Yes, sir.
The low signal out of the optimizer, the rich command, is about 0.36 volts.
Yeah, but anything under that, though, it's going to go to zero, the optimizer.
If the optimizer to go to zero means the oxygen sensor has to go below
0.3.
0.05 volts.
Exactly.
If the oxygen sensor signal goes below 0.05 volt, then the optimizer will go to zero. So,
But
I
that's
don't know that there is a quick, easy fix on this. The 4X, we're going to take the low signal from the optimizer, change it from that 0.35 down to about a quarter of a volt. That'll drop below that 0.300 volt mandatory low side that he's talking about. Is one of the refinements in the 4X optimizer. As far as taking a 3X and making it work, it'll still work, but you'll have a code.
Well, it goes in
okay, but let's say our regular oxygen sensor is what I'm saying, though. I would be curious to see it. Let's say that the regular oxygen sensor is doing this and it's not quite going. I'd be curious to look at this guy first.
The two new oxygen sensors we put in.
Okay, but let's say you got a dirty fuel injector and it's running a little fat.
Well, with the system not connected, it cycles beautiful, it is no problem.
Yeah, you're just saying that the optimizer doesn't allow the lower threshold to be seen
Right,
by the ECU.
right, yeah.
They want you,
And
man.
that's just part of the learning curve, I think, you know, man.
Right, I'm just bringing it up because if we can incorporate something in a newer product, then that's,
I know on the Chryslers, they came out with what they call a new generation controller, and they're sampling that. They're not only checking above and below 0.5, they're sampling that at all different points along that switchover, so that it's not just the middle. They want to see certain switching all along. Like they're hitting at 20, you know, they draw, like here's the graph, and they're sampling all along that.
Okay, well, if we get a vehicle, or you guys encounter a vehicle with an O2 that's just impossible to tune, I mean, that's why we can manipulate other sensors or tune other sensors that are also fuel controlling. The map sensor alone, I shaved off half. That's with a map sensor. I mean, there's other things that we can do other than just the O2. So if you get a car that's just impossible to mess with the O2, you keep getting a check engine light, well, then we need to use some other alternative to go about this. Because basically, your water gas, that's another thing, your water gas, you know, you guys might want to keep on top of that, those water gas levels. We've had cars in here, you can literally, when you turn the water gas off, they start running all shaky because you've tuned it to run with the water gas. Okay, you turn the water gas off, and now it runs all shaky. So you get a customer that's not paying attention or keeping on top of that water gas level. You definitely want to keep on top of that. As far as amperage goes too with flow, you know, did you go over the cleaning of the fuel cells and stuff? Okay, because I've ran into that too. So is there any other questions?
So the point you were making was that you could just bypass that part of the circuit and not use the oxygen
Until
sensor?
we get, or I get a little more, maybe I'll encounter something. I haven't quite encountered anything like that yet, but you know, there's other things you can
Is there a
do.
possible way to offset with a little circuit like we do with the AFR to shift the O2 sensor down a little bit?
We could try.
Yeah,
That may be a,
Yeah, just.
That would be a good one
Shift
to
the
pull
whole
on
thing
that,
down as a whole.
PT Cruiser and stuff, the Dodges with the 2.5 volt reference.
raised ground.